So is it okay now?
Yeah, perfect. Thank you. Go ahead.
Okay. Good afternoon here, my dear colleagues and the students. I'm very glad to give the invite presentation right from the 2022 Winter Olympic sites. So it make the presentation more interesting. So today I'm going to have an introduction about the project we are working on, which is very close to relation to the GMAP project. We are working on the key technology of the demonstration of the standardized planetary geological mapping. Actually, as you can see, all the participants from the Chinese university and institution are all get involved in the GMAP project. So I'm very glad to have an introduction for this project. Actually, we are thinking of this project because China has more and more international cooperation with the colleagues from the international community, especially from the European colleagues. And because in the future, China will have quite a lot of missions on Mars and the Moon and the asteroid and the Jupiters. So international cooperation is very more and more important for the missions. So we already have a very successful case for the Chang'e Chang 4 missions. We have a couple of international payloads which played a very good role in the successful mission. And I would see since 2017 that the scientists both from China and from the European countries, they established an international lunar research team which focusing on the scientific objectives for the future international lunar research station. Actually, for between the ESA and the CNSA, there's cooperation mechanism, the China-EU Space Cooperation Outline from 2015 and 2020. And also between the EU and the most of China, they established the framework co-funding mechanism on research and innovation cooperation. Thanks for the cooperation mechanism, so which make the project, the international project, come true since 2020. As I mentioned, the EuroPlanet 24, we all get involved in this project, and we have a very good collaboration with the GMAP project, which led by Mateo. And based on the cooperation, we applied the international cooperation project funded by most the Ministry of Science and Technology of China. And fortunately, we got the funding from the government, which support our joint research on the planetary geological mapping. Here is the brief introduction of this project. This project was funded by the National Key Research and Development Project program from the Ministry of Science and Technology of China. The period of this project is from December 1st, 2020 to 2023, November 30. So we have 5 topics on this project, which includes the topography mapping and the reconstruction of the subsurface structure of the lunar and the Moon, the Mars, and also the quantitative inversion of elements and the materials, the minerals on the planetary surfaces. And also we are going to establish the ground verification sites for the remote sensing inversion on the planetary surfaces, which is also a program on the Europlanet 2024 for the planetary larger size field program. And the final topic is the planetary geologic mapping, which will have a couple of demonstration geologic mapping on the Chinese missions. So this is the outline of this project. Concerning the first topic, the topographic mapping based on we call the cognitive enhancements, which is a very good, very new ideas to use the knowledges on the Earth for the topography and try to transfer to the Moon and other planets. And we are going to use the enhanced visualization to aid the extraction of the elements of the geological mapping. And also we were focusing on the topographic mapping on the Moon and planets and other planets. And the second topic is to reconstruct the subsurface geological structure based on the China's missions data sets. And we are focusing on the landing sites of the Chang'e 4, Chang'e 5 missions, and also the Zhizhong landing mission. We will have a very high resolution subsurface geological structure models. In the fourth topics, we're going to work on the quantitative inversion of the elements and the minerals on the planetary surface. The idea is focusing on the fusion of the spectral data acquired from multiple missions, either with the remote sensing way or the in-situ way or the sample emission analysis way to have a more stable spectral inversion database. And based on the database, we are having the quantitative inversion of the elements of mineral composition on the planetary surface. And we're going to establish a ground verification of the remote sensing inversion and also the geological mapping sites, which will be located in the China basin in China. We're very happy because this site has been assigned as the TA first, the facility 7, which already include in the facilities of the Europlanet 2024. So we're going to establish the ground verification field, both for the planetary geological mapping and also for the spectral inversion methodologies. And the fifth topic is about the standardization and the demonstration of the planetary geological mapping. In these topics, we'll be focusing on the high resolution geological mapping for the landing sites areas. And here is the flowchart of the methodologies. And the ideas is we're trying to form standardized technology of the multiple dimensional digital geological mapping by extending the single two-dimensional geological map to the geological structure map and also the three-dimensional geological model. So we are also have the demonstration on the ongoing or the coming mission from the China Space Agency. Here is the flow chart of the whole project. I would see the very new ideas is where we are going to use the enhanced diffusion of the relief and the spectrum, plus together with the artificial intelligence to extract the elements for the geological mapping. And also we try to standardize the geological mapping for a specific purpose like the engineering and also the innovation research purpose. Within this project, we have quite a good collaboration between both the Chinese university and the European universities. Here is the timetable of this project. We started the project from December of 2020, and we're going to finish it before November 2023. I would see the organization of this project is based on the research institute, the Center for International Cooperation on Lunar and Planetary Exploration, which was supervised by the Ministry of Education in China. And all the Chinese participants get involved in this the center. We also have the 3 professors from the GMAP as the academic committee for this subcenter. As I mentioned, all the institution has participated in the European Planet 2024. The CUGB and the Peking University, Wuhan University, and the Shandong University get involved in the GMAP working package. And the National Space Science Research Center is involved in the working package 11 and working package 2 and 3, which are focusing on the established facility of the planetary analogous field size. And I would see our main roles to contribute to the Europe Planet 2024 is we will be focusing on the geological mapping using the China's ongoing and planning missions dataset. So I would like to have an introduction of the brief introduction of the China's ongoing or planning missions. As you may know, we have successfully implemented the Chang'e 1 to Chang'e 5 missions. And later we are going to have Chang'e 6 and the Chang'e 7 missions to the South Pole. Chang'e 6 will implement the sample returning mission, and the Chang'e 7 will implement the mission to explore the PSR and the region of the South Pole of the Moon. And the Chang'e 8 will be the prototype of the International Research Station. And I will see you are quite familiar with the ISCG Global Exploration Roadmap, which was released in 2018. We are very happy because China has the contribution on the from Chang'e 6 to Chang'e 8 lunar exploration, and also the planetary exploration like the Mars, asteroids, and the Jupiter exploration missions. And I would like to have a brief introduction of the ongoing Tianwen 1 missions. The Tianwen 1 mission is the first Chinese mission to explore the Mars. It was launched on the July 23rd on 2020 and landed in the south of the Martian utopian planet on May 50th, 2021. For this mission, it has 5 scientific objectives to start in the Martian topography, geomorphology, and geology characterizations, and to characterize the soil and its water ice content, to determine the composition of the surface material, to provide the Martian ionosphere, climate, and environment, and to constrain the gravity and the magnetic fields, and also the interior structure. For fulfill the scientific objectives, the Tianwen mission have 7 payloads aboard the orbiters and 6 payloads aboard the rover Zhizhong. And I will see the payloads covered quite well on the scientific objectives I introduced previously. And as of the February 4th of 2022, the orbiter has been in orbit for 561 days. And for the Zhizhong rovers, we are very happy to see it traveled more than 1.5 kilometers, and now is heading to the south for the purpose of approaching the border between the Martian Ocean and the land, to try to explore more scientific objectives. And actually, 2022, I mean, the last month, the January of 28, the State Council Information Office of the Chinese government released the white paper. The white paper have a summary of the previous missions, and also show the perspective for the next 5 years, China's space program. First, the white paper have a summary on the Chang'e 4 missions, which is the first humanity's first soft landing on the far side of the moon. And the mission is still ongoing, and now is on its 38th lunar day detection, and the rover have traveled about 1,000 meters away. So here are the data set acquired by the rover. The scientists are working on the new data set for the new discovery of the far side of the moon. Concerning the Chang'e 5 mission, was also very successful. And the mission brought back the 1,731 grams of lunar samples. And the Chinese scientists are working on the samples, as plenty of very good scientific discovery about the new age and the younger age, and the dry crust, and so we are looking for more new discovery based on the sample analysis. I'm very excited. We are very excited because the white paper released the planetary exploration planning for the next 5 years. We are going to launch the Chang'e 6 and Chang'e 7 missions to the South Pole. And we are going to complete the research and development phase on the key technology of Chang'e 8, which will be the prototype of the International Lunar Research Station. And we're going to launch the asteroid probes to sample the near-Earth asteroid and probe the main-bed comets. And we are going to have the Mars sampling return mission. and to explore the Jupiter system, and also to study plans for the boundary exploration of the solar system. There's another quite exciting plan is the International Lunar Research Station, which now were officially announced by both of the Chinese and the Russian government. And the IARS is expected to build on the lunar surface for the purpose of the jointly carry out multiple disciplinary and multiple objective scientific research activities, such as the lunar exploration and utilization, lunar-based observation, basic scientific experiments, and the technical verification. Actually, the International Lunar Research Station will compress 3 phases. The first phase is the reconnaissance phases, where have the Chang'e 4 to Chang'e 8 missions, and also the Russian lunar missions. And the second phase will be the reconstruction mission. The phase, so we will have several specific missions for the International Lunar Research Station. After the construction phase, we're going to have the utilize of the International Lunar Research Station. The main scientific objectives have 8 aspects. The lunar topography, geomorphology, and the geological structure, lunar physics and the internal structure, lunar chemistry, cislunar space environment, lunar-based astronomical observations, lunar-based Earth observation, and the lunar-based biological and medical environment, and also the lunar IS and the Lunar Resource Institute utilization. Actually, this project is open for the international cooperation. As we can see from the tables, for every phase of the International Lunar Research Station, the cooperation are open for a different level. And the different level can be space mission, system, subsystem, equipment, and also the group ground application. And also the scientific objective proposed is also open for the international cooperation. So for the detail, you can reach the website for the introduction of the International Lunar Research Station.
Less than 5 minutes left.
Okay, thank you. So within this project, we have worked on a couple of research facing the Martian mission and also the lunar mission of China. This is the research we are using the Tianwen mission dataset to do the strata structure interpretation. We have some very interesting discovery about the local volcanism, and also the structure of the subsurface of the Zhizhong landing sites. We also have the research on the Chang'e 4 landing sites by counting the degrading craters, which we have a very interesting discovery by comparing the CSFD slope with different level of the degraded craters. We found that the slope is the contrary to previous research for the far side of the moon. The smaller the size of the craters are, the more difficult for them to reach the impact balance. We also had the research on the interpretation of the basalt source in the Chang'e 5 landing areas, which we believe is very important for for the sampling analysis to figure out the formation of the basalts of the landesite, and also can trace to the source of the samples. And we found very interesting phenomena is the landesite is located at a boundary of the two cans of the basalts. They are exactly located at the border of the magnetized and the non-magnetized regions. So we believe if we are working on the sample analysis, we can figure out the reason which we found at the border of the magnetic field. And at present, we are working on the related planetary geologic maps, which we have the maps for the Chang'e 3 missions, and also we have the maps for the landesite selection of the International Lunar Research Station. We also have the three-dimensional substructure of the Zhizhong landesite region. In the future, we are going to, next year, we are going to have specific high-resolution geological maps for Chang'e 5 and the Tianwen 1 missions. We're going to have more three-dimensional geological models. And here is our contribution for the International Lunar Research Station. And here we can see a video clip for the official promotion video from the International Lunar Research Station. So for the first phase of the IRSL, the Chang'e 4 to Chang'e 8 missions will be implemented. So we're very happy because in the video had included several potential landesites. One of the Amazon crater was included in this video. So we're very happy because
2 minutes
okay, we're finishing. Thank you. So this is kind of work we are working on the IRSR landesite selection. And this is the publication from 2020 to 2021. We have a couple of papers published in GRL and DGR and ICROS. And we are looking for more in the next year. So the task in 2022, this year, we are focusing on the geology mapping, focusing on the Chang'e 5 and the Tianwen 1 landing areas. And another very important task is this year we're going to implement the experiments on the Martian analog field. We're going to visit the area and to do both the remote sensing and the in-situ measurements, to do the ground verification of both of the planetary geologic mapping and also the remote sensing reversement. Okay, so this is an introduction for this project. I hope we can have more cooperation, both offline and inline with our European colleagues to make more contribution from China to the European Planet 2024. Okay, thank you very much.